All right. I think we've given enough of a buffer window for everybody to start joining the webinar. So I'll hand it off to Suzanne to kick us off.
Thanks, Pamela, and thanks everyone for joining. We're excited to have you here for this Unitycatalog workshop. Today's presenters will be myself and Pamela. We're both solution architects here at Databricks. So just some housekeeping rules. Your connection will be muted. We're using webinar style mode. And so you can submit your questions in the Q&A panel, and we have a host of TAs who will help answer those questions throughout. And please remember that this session will be recorded, so you'll have access to the recording and the slides within 1 to 2 days after this presentation. So let's get started. So Databricks Unitycatalog is our unified governance layer for all of our data and AI assets. It helps us monitor our data, audit it as well, and share data assets between different workspaces. We use it to control access to all data and AI assets in a unified way. And it's now all open source as of the Data and AI Summit this June. So Databricks Lakehouse unifies our governance layer. It does that by having Unitycatalog handle all of the connectivity between external sources to federate with external catalogs, to control access to your storage layer, and also interact with all of your workloads. And it powers Databricks IQ, which is our intelligence layer integrated throughout the platform. So let's talk a little bit about how Unitycatalog connects to our cloud providers. So some of the questions we get around deployment are, where does Unitycatalog fit in my cloud deployment? And how do I think about the roles that will interact with Unitycatalog? So at a high level, Unitycatalog lives within your Databricks E2 account. Within AWS, you can have your E2 account connect to multiple AWS accounts. Within Azure, it's tied to your Azure AD tenant, and in GCP, similarly in Azure at your organization level. And it is regional based. When we think about the roles within the Databricks landscape, at the top, we have our account admin role. This is the most privileged role within Databricks. This should generally be allocated to a platform ops team or an administrative team, because they'll have all the permissions and powers that within the platform. Underneath that, we have our workspace admin, our Unitycatalog admin, and also our marketplace admin. The workspace admin is a familiar role. This is the role that sets up permissions for users within the account and can manage permissions, for instance, to let people create, compute, or to use different resources within your workspace. The Unitycatalog Metastore admin is an important role which controls all the functionalities within a Metastore. They can manage catalog to workspace bindings, and it also should be allocated to central ops team or governance team, since they have very elevated admin permissions. Underneath the Metastore admins, we have catalog owners, schema owners, and table and view owners. Catalog owners is also a very useful role for enabling someone to have ownership over complete catalog, for instance, such as within a data domain or within a business unit. A schema owner can be someone underneath that which has permissions over the schema and the table volumes and models and functions within that. Our marketplace admin is a new role which manages your permissions and your provider profile within your Delta sharing and within the marketplace. At the high level, Unitycatalog has a 3-level namespace. So we have the Unitycatalog Metastore, under which you can allocate and create many catalogs and schemas. Looking at the permissioning model, the Metastore admin has permission over the whole of this system. The catalog admin has permission over the catalog, and the schema admin under that. The Metastore admin can also create storage credentials, external locations, and Delta shares. It's best practice when setting up your unicatalog permissions to not allocate these to a single user, but instead to allocate them to a group. This is really useful if you have people who are moving out of teams or who aren't available for a day. This really creates a better practice within your administrative flow. And also you should set up your unicatalog permissions to align with whatever your SOPs are within your organization. So let's get started with the Metastore. So we get a lot of questions around how to set up a Metastore. What kind of storage configuration do I need to set up? And what are the best practices for configuration? If you created your workspace since November of last year, you more than likely were given a default or automated Metastore. In this case, the Metastore is already created for you with unallocated storage, which you have to dedicate. And it also has underneath that a dedicated catalog and ownership given to the workspace admin. If you created your Metastore before November, or you've taken the manual approach, you would see this screen, which is very familiar within the account console. Within the account console, you need to set up the Metastore name, you need to allocate it to a region, give it a storage credential, and also set up the default storage location for your Metastore, which will be considered your Metastore root storage. Then you need to assign this Metastore to the workspaces using workspace to Metastore bindings. So how to think about managed storage within unicatalog. Within unicatalog, we can set up storage at multiple levels. As I mentioned before, when you set up your Metastore, you have to set up a default Metastore storage location. When you do that, you're creating a maintained or managed storage container. Within your Metastore, you can also create catalog and schema level storage as well. And the lower levels will supersede the higher levels of storage, which means that if I'm saving a table into a schema with its own predetermined or pre-allocated storage location, then the data will save into that storage location instead of within the catalog or the Metastore root. Best practice is to actually set up your storage at the catalog level. The value of doing that, it allows you to have separation and isolation between different catalogs and enable you to follow better standards and procedures for data isolation. So let's talk a little bit about registry and discovery of your data. So a lot of the questions we get around unicatalog objects and creation of data is what objects are within unicatalog, what's stored there? What permissions do I need to have access to these secureable objects? How do I organize my data best? How does UC help with data discovery and productivity? And what should I be doing to help my users discover the relevant data assets? So with the creation of unicatalog, we now have a three-level namespace. On the top, we have our Metastore root, and underneath that, we have our catalog and schema. In the schema level, this is where we can manage all of our files through volumes, all of our models and functions, as well as our tables. And we can create either managed or external tables, and we can talk a little bit about the differences between those as well. Alongside that, we can set up foreign catalogs, have access to the Hive legacy Metastore, and also a shared catalog, where shared catalogs are catalogs shared to us through Delta sharing, and foreign catalogs are catalogs created on external sources, such as external Postgres or other databases as well. So data assets are one of the things that we can govern within unicatalog. So when setting up data assets, we need to set up storage credentials. Storage credentials create the permissions for accessing external locations. So storage credentials can be used for multiple storage locations and require you to have some kind of Azure Managed Identity or IAM role defined to give Databricks and unicatalog access to those storage locations. And they need to be created by a Metastore admin. External locations use these storage credentials to get access to underlying storage. The value of leveraging storage locations and external locations, or storage credentials and external locations over previously used mount points, is that it abstracts away the access to these underlying storage, and you can also set up permissions for individuals or groups to have access to specific storage credentials and external locations, and make sure that they only have the amount of access that they need. Volumes is the unicatalog solution for storing arbitrary files not in table format. This is super valuable because it enables us to have access to file-based like exploration and data types without having to have access to the underlying storage. We can create volumes on top of external locations and set up file and folder structures and explore it directly within unicatalog, similar to how you would explore it in a storage type scenario. We can create both managed and external volumes. If we're creating a managed volume, the storage will be the same as it is in our schema or our catalog, or the higher level of Metastore, depending on how we define the storage locations, depending on how we define that storage path. Or we can create an external volume where we define a separate external location. And you can do this all within the UI, and we can also do this programmatically as well. This table has a lot of detail on the difference between managed and unmanaged or external tables, and you'll get these in the slides afterwards. But most importantly, I want to call out that managed tables, when you set those up, when you drop a table, you're also dropping the data because it's fully managed by unicatalog. Whereas an external table, if you drop a table, you need to go in and have a separate process to clean up all those extra files. Additionally, with managed tables, you have performance optimizations already turned on. So predictive optimization will be turned on to your tables, which enables auto-optimize and clustering for you as well. Whereas unmanaged tables, you'll have to turn that on by yourself. Additionally, all new feature updates will be pushed to managed tables first, with support for external tables coming later. So the best practice that we recommend is to use managed tables unless you have an important reason for not using them. There's been many advances within managed tables to enable interoperability between managed tables and other external tools, which are just improving the offering of managed tables overall and making your life easier as an admin. Lakehouse Federation is how unicatalog can connect to external sources. It allows us to create and abstract away these credentials for connecting to these external sources. And then on top of that, we can create foreign catalogs to access the data natively like we would access any other data in unicatalog. Today, you can see some of the supported sources and some of the sources that are coming on our roadmap, such as Oracle and Salesforce in the roadmap for support through Lakehouse Federation. When creating a foreign catalog, or when creating a Lakehouse federated source, you need to create a connection. By doing that, we need to make sure we have all of the credentials set up, and we can create the connection directly within unitycatalog by giving the relevant permissions. Foreign catalogs are created on top of these Lakehouse federated sources. And what you can do is just set up a catalog pointing to this source, and then you can manage permissions to these catalog objects, similarly to how you manage permissions to all unicatalog objects. So within unicatalog, we don't only manage our data assets, we also have the ability to manage our AI assets. One important asset that we manage within unicatalog are our features. So within the feature store, we can see our unicatalog tables if they've been defined with a primary key. When we create a table and set up primary keys on top of our columns, we then have access to these tables within the feature store for discovery and also for reuse across multiple models. Within unitycatalog at the schema level, we manage our models and we can store them and be able to share them across different workspaces that way as well. Within unitycatalog, we can store multiple versions of the models, and we can also alias them for use in the model training and serving lifecycle. When we create these models in unitycatalog, we can also set up permissions similarly to how we set up permissions for tables or other assets. So I can manage them very granularly. Lastly, functions are one of the solutions that we can also manage within unitycatalog. We can have both Python and also SQL-based functions live within our schema, and we can register those directly within unitycatalog as well and manage those permissions for usage. An important use case for these functions is when we're setting up row or column level filters. We can store these stored procedure type functions directly within unitycatalog. And lastly, our vector search index. Our vector search index is a new and very important solution for supporting GenAI applications. For instance, we use these a lot when setting up databases for RAG implementations. We can set up them directly within the UI with one click or using the API as well. Using a table defined in unitycatalog, we can create a vector search index on it, defining our embeddings and also our primary keys and giving it an endpoint location. And then with a click of a button, we can set up a vector search index, which is stored alongside our tables in unitycatalog, again, where we can manage the permissions. So unitycatalog really enables us to have streamlined discovery and lineage. Within unitycatalog, and within the whole Databricks platform, we can take advantage of Databricks IQ, which is our intelligence layer within the whole Lakehouse. Built into unitycatalog, we can actually auto-generate column and also table level descriptions. This is super helpful for searching and discovery and for supporting many other AI-based operations within the platform, such as our AI BI spaces, which leverage this rich metadata generated by our AIs to help create better queries. This is super helpful for folks who need to create metadata quickly and can generate it with the AI and then go through with an approval process to accept any of the suggestions. And it makes it much easier for searchability. The best practice here is to actually add tags when you generate any objects within unitycatalog for searchability, and also to leverage these comments early and often so that you can increase searchability and discovery within your workspace. Now with unified search within the workspace and within unitycatalog, we can take advantage of searching across all of our assets, our notebooks, our dashboards, and our data assets, of course, by leveraging the unified search. And when we add tags, we have even more metadata on top of that to improve searchability. For instance, if I was creating data assets and then onboarding new BI users, I can add tags relevant to their field or department for them to be able to more easily discover and access the data and get started on their journey. One of my favorite things about unitycatalog is the automated lineage. So this is something that's built directly into unitycatalog, and all you need to do is store your assets within the unitycatalog and then run your workloads. In the back end, unitycatalog will do all of the generation of this lineage, both at the table level, but most importantly at the column level. This has super important implications for instance, any auditing or any regulatory compliance that you need to do on your data. You can trace back any features or any columns that are relevant back to the upstream sources, and actually also back to any files or any federated tables or sources that you use as well. One of the newest things that we're excited to announce, which is now in private preview, is bring your own lineage. And what this enables you to do is have a more complete picture of your lineage within unitycatalog. So not just having the lineage, which is generated directly within unitycatalog by running your workloads in Databricks, but you can also augment that with your upstream and downstream lineage, for instance, from your streaming sources and from any downstream reports in Power BI, for instance. And this is really all in an effort to help you have a more richer experience of discovery and searchability within Databricks. So let's switch over to the workspace for a demo. Okay. So here you can see my workspace.
Suzanne, I think you're not sharing anymore.
Oh, I'm not sharing anymore. Sorry. Let me, 1 second. Okay. Okay, perfect. So here we can see my Databricks workspace. So if you haven't seen a Databricks workspace before, this is in my catalog landing page. And here we can see on the sidebar, these are all the different components that I can access within my workspace. So right now we're going to start at the catalog and then we'll go from there. So within my catalog, I can see that I have multiple catalogs defined. And then under that, I have multiple schemas. And also at the schema level, I have my tables and also my volumes. So if I wanted to create a new catalog, I can just go here and press add data. When I click add a catalog, I can give a catalog name and I can pick a standard catalog, a foreign catalog, or a shared catalog, where a foreign catalog will connect to one of these federated sources and a shared catalog will be shared to us through Delta sharing. We can also set up a storage location for our catalog assets, or we can leave it blank and use the Metastore location already set up. So if we click into here, I'm just going to click into my UC web schema, and then from here, or my catalog, and click into my Metastore schema. Within the Metastore schema, I can see that I have tables, I have volumes, I have models, and I have functions. Let's look at the volumes first. So within volumes, I have some different locations set up. I have my files volume set up, and within that, I have different sources. So in this case, I have some Metastore data from different years, and I can click through and actually view the data very similarly to how I would view it in a normal storage explorer. I can set up permissions on these files, I can grant and revoke them, and I can set up really granular permissions to make sure that I'm adhering to the principle of least privilege. From these files, I can adjust them and create tables. So if I click into my schema again, I can see that I have 7 tables defined. Let's look at one of these tables. So we're looking at one of my tables, and within the unitycatalog Explorer, I can see I have my column names of my tables, I have any primary and foreign keys defined, I have my data types defined, and I can also add any comments to my columns and table description manually, or I can do it using the AI generate functionality. So if I click on the AI generate, I can see here that many comments have been created for me, and I can go through and accept them. I can also edit them as well. This makes it super easy and quick for you to augment your data as you create it with a lot of this metadata so that it improves searchability. So for instance, if I were to now go into my search bar and say I want to look for beneficiaries over 65 years old, it would pull up that column comment that I just generated using AI and pull directly towards these columns in the unified search for me, which is super helpful. Clicking through, I can look at some sample data. I can see my column names and my data types. I can see the details of the table. So in this case, I can see that it's a managed table. So now I know that it has predictive optimization turned on for me by default. And then I can also see the permissions. So I can grant permissions similarly to how I showed you, you can grant permissions on any files within a volume. I can also grant permissions at the table level to a group or also to a user. Clicking through again, we can also not just do this how I showed you in the UI, but we can also do this programmatically. So let me go to my notebook. I'm going to click into my workspace, which is where I save all of my notebooks and my other code assets. And I can click into this notebook. In my Create Data Pipeline notebook, I can use ANSI SQL to create my catalog and also my schema. I can also define my table and the table columns. And I can use keywords, primary key and foreign key, to define the foreign keys and primary keys within my table. And additionally, I can also, in one block of code, create a table, insert data into that table, and read files from my volume. And I showed you before how I manage permissions to the data in the volume and also to the table that I defined in the catalog. So all of this can be done both within the UI and also within code. If I go back to the catalog that we were just in, as you saw that we defined some primary keys and foreign keys, I can use that to view an automatically generated entity relationship diagram. So this is super helpful because now I'm able to just generate this entity relationship diagram directly just by using the primary and foreign key definitions. Additionally, since these tables have been defined with primary keys, they actually automatically become feature tables. So if we click into the feature table section of my workspace, I can see all of my feature tables defined in unitycatalog. Using searchability and the tags that I've created on these tables, I can filter to a specific tag. And then I, for instance, can use this table now as a feature table within a model training or within a model. So going back to my unitycatalog, again, if we click back into catalog and we go back to my Medicare schema, I also have a model defined. So I've defined this cost model, which will help me predict the costs of these medications. If I click into it, I can see that I have one version of this model created. I can see when it was created. I can see any aliases that I've added to it, who owned it, and I can additionally add any comments or tags to it as well to improve searchability. On this model, similar to any other asset within unitycatalog, I can grant or revoke different permissions so that I can allow people to use the model or to even view it. If I click into this version, I can even see information about the model training. So I can see here that this model was created by this training run. And if I click into this, I get redirected to the MLflow experiments tab. And in here, I get more information about that model training run. I can see more details about it. I can see some of the metrics that I defined for this run. And then I can also click into and see the notebook. If I click into this notebook, I can see that I actually used AutoML to generate this model, which is our glass box machine learning solution. And then from this, I was able to register the model and then serve the model and use it to predict. So if I go back to my catalog explorer and I go back to my schema, I use this model to predict the cost of medications and output this predictions table. I'm going to click into this predictions table and I can see here that There's some, we have our schema here. I can add some comments as well to describe what the table is about. And I can also see the lineage, so I can see how this table was defined. So if I click See Lineage Graph, I can see that this predictions table was dependent on the training data. And if I expand this out, I can see that upstream to this training table, it depended on multiple other tables, one of which is actually a federated table from a Snowflake source. Some of the other tables, if I expand those out as well, I can see depend on data from my landing zone in my volume. So what's really great about this is that this gives me a complete view of my lineage of my output predictions at the table level. But more excitingly, if we look at some of the outputs, such as, for instance, my prediction column, I can see that this depends on multiple features from this upstream feature table. And that this column, for instance, depends on inputs from another table upstream. And so I can get a complete view of this full picture just by leveraging the lineage inbuilt into unitycatalog. And with the lineage, bring your own lineage preview, we can add further upstream and downstream sources to get a more complete view for data discovery. And lastly, we can create a vector search. So if I go into my training data, which I use as input to my machine learning model, if I wanted, for instance, to use this as input to a RAG implementation, I can create a vector search index just with one click within the UI and also using our API as well. So here I can see I can create a vector search index name. I can create a primary key. And then I can also allocate it to an endpoint, which will be responsible for updating this vector search index. And I can also select any embedding that I want to use for this vector search index. And then I can set that up. And when I set that up, it'll exist as a table within unitycatalog. And I can also define any permissions for access to that directly within unitycatalog as well, similarly to how we define permissions for any other asset within unitycatalog. So that was a very quick and comprehensive demo of unitycatalog. So we just went through and we looked at, within a Metastore, we looked at a specific catalog. Within that, we looked at tables, volumes, models, and we discussed how we can manage permissions of these each individually. We've shown how to do that within the UI and also programmatically in a notebook. We set up a vector search index, and we also looked at how defining primary keys on tables enable us to both have automatically created feature tables and also entity resolution diagrams. And then we use those and showed the downstream lineage of a particular table from an output model run. And all of this has been managed within unitycatalog using a lot of the features and functions and discoverability that we just discussed within the previous slides. So now I'm going to pass it off to Pamela, and she's going to talk a little bit more about the exciting features within unitycatalog.
Yeah, thanks, Suzanne. So I'm going to pick up where Suzanne left off. So if we've created all of our unitycatalog data and AI assets, now we want to make sure that we have the ability to share those both internally and externally across our organization. So this is one of the key questions that we get. Not only how do we share it, but how do we make it simple, quick, and make sure that it is secured. So internally, one of the key pieces that we have to making sure users can consume these data sets is really empowering them to understand the data sets. And that's where Databricks IQ comes in. This is the intelligence engine that leverages all of that rich metadata that Suzanne just showed you within unitycatalog to power both our Databricks assistant, which you can ask questions about as you're interacting or querying against the data, as well as our AI BI Genie. So AI BI Genie is a natural language query for everybody. It's a no-code experience that allows your analyst to share data sets that users can interact with in natural language. Analysts are able to curate these different Genie spaces with subsets of data assets. And as users interact with them, you're actually able to monitor the questions, the answers, and the feedback from the users, whether or not those are helpful. And all of the governance that we have is layered into this platform. If we want to share our data sets externally, that's where Delta sharing comes in. So this is an open standard for secure sharing of tables, views, files, models, notebooks, anything you like. And it's all governed through that same Unity catalog governance model. So you have a data provider that can use the Delta sharing protocol to share assets with data consumers without any replication. And these users don't even have to be using Databricks downstream. We also offer your Databricks, the Databricks Marketplace, which is an open marketplace for all of those data assets. And this marketplace is powered by Delta sharing. So for data providers, this is a great way to monetize new assets, whether those are data tables themselves or solution accelerators and notebooks. It gives you a way to increase customer reach and no replication of your data is required. For data consumers, this gives you a way to discover new data and AI assets, especially assets that might complement some of the proprietary data sets you have. For example, demographics data or weather data that you might want to use to add additional context and meaning to the data pipelines that you've built out. And currently in a preview state, we have Databricks clean rooms. So this is a privacy safe collaboration space for data and AI. So it's flexible with native support for machine learning and Python. It's cross-platform and cross-cloud support. And it really allows you to manage complex workloads at scale when you're working with other third parties. So we want to be able to share all this data across our organization, but we also want to make sure that it's secure. So some permission questions that we get is, how do we actually manage permissions on these data assets? And how can we apply fine-grained permissions like row and level filtering and column masking or attribute-based access controls? So as you saw, Suzanne, as she was giving the demo as we created all of these assets, within the UI, you can very easily, in a point-and-click manner, apply permissions to individuals or groups of users across all the different data and AI assets that you have. You can also do this programmatically using ANSI SQL. So you can use the grant command to grant some privilege on some securable asset, whether that's the volume, the model, the catalog, the schema, the tables, to some identity. So that might be your individual users or groups. Coming soon, we'll also facilitate requests for access. And so this will combine the currently new feature that we have, which is browse, which allows your users to discover assets before they can actually interact with them. But in private preview soon, they'll also be able to leverage that browse functionality to request access to those data assets. You can configure request for access to set email or Slack destinations or integrate with other workflows. So the users will be able to discover the asset, request access, and then your admin can approve access to that asset. So it really gives a seamless way to take all that programmatic work that we're doing to manage the permissions of our assets today and use that for automation and seamlessly allowing users to consume those assets without any additional steps. Aside from the assets themselves, we also want to make sure that we have row level security and column level masking across our tables. So as Suzanne mentioned, we can create a function, and this can be a standardized function that we use across tables. So once our function is created and our logic is configured, depending on what we want to show or hide to the end users, you can apply that same single function across multiple tables and reuse across multiple columns. And all of this governance that we have, you can manage it like we saw in the UI, you can manage it through scripts, but you can also manage this with Terraform or through APIs. So this might fit really well into any DevOps infrastructure as code type scripts that you might have to maintain your workspace deployments. All right, so let's get into our first demo. And I'm going to pick up where Suzanne left off. So I am currently in a Databricks workspace. I'm in a SQL editor here. And you can see I'm interacting with the same data sets that Suzanne interacted with. So I can run a select here against this geo table, and I'll be able to see the data across all of these different states here. I can run a select against my federated data set. So this is the Snowflake table that we've used to build our training data set. And I can see all of this prescriber NPI data sets here. So we're going to do two things. We're going to create a function to mask the NPI if a user is not a member of the HR admin group. And then we're also going to create a function to filter out states. So if you're not a member of the geo group, then you will only be able to see 3 states, New York, New Jersey, and Connecticut. So I'll go ahead and run these 2 commands here. And if we jump over to our catalog, we'll be able to see those 2 functions defined directly in that same schema that Suzanne was looking at previously. So we have those volumes, the tables, and now we have those functions registered here as well. If I look at the groups that I am a member of, we'll see that I'm not a member of the HR admin group, and I'm not a member of the geo group here. So once I apply these functions onto the respective columns of each of these tables, we'll see that I'll get a abridged data set that is respecting the logic that we put in place here. So because I'm not a member of these 2 groups, then I'll be able to only see the data assets that I should be allowed to see. So we'll just set up these 2 functions here. And if I repeat my query, I'll see now that the CMS provider table is going to mask the NPI column for me. So you can see I can no longer see those ID numbers here. And if I do the same query against that geo table, where I could previously see all of the available states, now I can only see the 3 selected states that I should be allowed to see. And just so that we're super clear here, these same types of row and column level security are applied against those federated assets, as well as the Delta tables that you're creating within Databricks. And all of this is managed and able to be managed because we have that single layer of unified governance across these assets. So now that I have my security set up, I want to allow my users to consume this data set. So I have all these assets within my Medicare schema, but I think I might just want one more. So we have all the proprietary data sets that we have, but I think I want to mix in some demographics data so that we're able to get some richer metrics when we work with that data. So if I go to the marketplace, this is the open marketplace powered by Databricks Delta sharing. So just let me get my search term here. So I want to look at some zip code metadata, and I'll choose the free option here. And this one looks good here. So here I have a data asset that I can open and integrate within my catalog right next to all my other tables. So if I go back to my catalog explorer here, I'll be able to see assets that are shared with me. And I can see this demographics information that includes that data set that I'm looking to get, this zip code metadata powered by Delta sharing. And I want to make it easy for my users to combine this data with the proprietary data that I have. And so that's where we leverage all of this information from unitycatalog to power our Genie spaces. So a Genie space is where we can create a space. We can give it a name. You see webinar. We can choose a warehouse. So this is powered by a serverless SQL warehouse here. And then we can select our catalogs, our schemas, and select whatever tables we want to include for our users to be able to run queries against. So I have my demographics data here. And I can also get my federated data here. So you can see here I have Delta tables that are written out in my storage. I have some complementary demographics data openly shared through Delta sharing, and I have federated data from Snowflake. So I can save this Genie room here. And then this is the UI that I can share with my consumers to start empowering them to interact with this data set. And all of this information is going to be powered by that metadata that we have within the unitycatalog environment. So if we want to, we can add additional instructions here. We can provide it with sample queries or sample questions that users should use. But you can see with very little information, it provides natural language descriptions of what these tables are and how they're connected. So I can ask questions of this data. For example, here, who are the top 5 prescribers by name and NPI with the most claims? And so what's interesting about this is you'll remember that I applied that column masking on top of the NPI column so that I am not able to see those identifiers. What Genie is doing under the hood is it's translating my question here, leveraging the metadata of the data assets that I've included here, generating a query against the correct data assets, and then returning to me the response from that query with the respective data information that I'll need. And so this query here, once it completes, should show us the masked data as a part of our response. And you can see here that this is actually choosing correctly that federated data asset. It's joining against the appropriate information on the appropriate keys, leveraging those primary and foreign keys that we set up on these assets here so that we're able to get back the correct response. And something always has to go wrong with a demo. So lucky I've got a backup here. So here we can see the same setup. I included the same data assets here. And when I ask the same question, we can see that same generated query that we were looking at before, along with the filtered data set that we're looking at. When I ask a next question, like what is the total drug cost for beneficiaries over 65 by abbreviated state for the year 2020, I'm able to get back again the subset of information that I have access to. So New York, New Jersey, Connecticut. I can ask a question about that Delta shared data that I have, and that will provide me the full scope of data. So this is that demographics information that we included here. And we can see the generated query here is going against that demographics table. And then finally, I can even ask complex questions like joining the results from the previous query about drug costs by state and showing me a per capita drug cost by state. So this brings together the information from my demographics data along with the secure data that I have for my table. And then I can even give it a command to visualize this information and get a graph directly within the Genie workspace. And all of these questions and answers are included in a monitoring framework. So we're able to see those questions as answers, as well as what ratings the users are giving the information that gets returned. So we took a look at the row and column level security, but what we'd really want to grow into is the attribute-based access controls, the preview of which is coming soon. So this scales that access management so that we can set policies, securable policies, using tags, location, identity, time attributes within the same framework of SQL and UI-based authoring. So first primary use case that most users ask about is masking all columns tagged with PII information. We don't want to have to manually, like we do today, alter each table and apply the function on every column where there is PII data. We'd rather have those columns tagged, have one rule that will automatically apply that masking function whenever the column is tagged with that PII tag here. Another use case would be a time-based use case. So we want to grant all ML models in a schema, but only for 90 days, maybe for like a data science use case that users are only working on a small project here. So we can grant, maybe do a little sleep index here and then revoke. But what we'd love to be able to do is a time-based grant. So coming soon, you'll be able to set a rule on your schema and leverage time, relative time, to be able to revoke access or only grant access for a temporary amount of time here. And then finally, for all of those catalogs, schemas, objects that we have within Unity Catalog, we might want users to be able to work within those, but we might not want those owners to actually manage the permissions for those assets. So right now, if a user creates a schema, as the owner of that schema, they'll be able to manage all permissions to those data assets. In the future, what will come with attribute-based access control is we can set a rule to deny the managing of grants, except for specific users. This gives us better security, better control of who is actually going to be interacting with data and being able to access the data that we're working with. So we have all of our data and AI assets. We've got this single pane of glass into those assets. We've secured them. We're sharing them both internally and externally. Now we want to have visibility into everything that's happening. How do we answer questions about usage patterns, configuration changes? How do we monitor usage and cost to ensure we're staying in budget? And how do you monitor the data moving through all these pipelines and the quality of those data and AI assets over time? So the first piece that we have here is Lakehouse monitoring. Lakehouse monitoring is unified monitoring for reliable insights into all of the data moving through your pipelines and all of the data coming out of your models. So it generates out-of-the-box tables for profiling the data assets as they're refreshed, as well as an out-of-the-box dashboard, so you can start to understand the metrics that are being captured as a part of your Lakehouse monitor. And because these metrics are all stored as Delta tables, you can do proactive alerting on top of these monitor metrics and drift metrics to be able to take action if your data is trending in a direction that you wouldn't expect. In addition to Lakehouse monitoring, we also have Lakehouse observability in the form of our out-of-the-box system tables. So system tables powers all insights into cost and usage analytics, efficiency analytics, so which workloads are costing the most, using the most compute, audit analytics, how many users have created new tables in the past week, the past month, who's deleted assets, whether those are notebooks or models or experiments, as well as the data quality analytics that we mentioned before. So you can query these system tables directly using straight ANSI SQL, but we also have a AIBI cost dashboard that your account admins can automatically deploy out of the box to your Databricks workspaces. These are out-of-the-box dashboards that leverage system tables to help you start answering questions without you having to build that table from scratch. In addition to these out-of-the-box AIBI dashboards, you'll also have the ability to set up alerts with our new budgeting feature. So this allows you to set a budget and then be able to track against that budget, leveraging all of the data and usage metrics that get surfaced up from system tables. And so these two features are in a preview state, but we'll be able to interact directly with those system tables and Lakehouse monitoring to start getting those answers. So if I go back to my catalog, we had a collection of tables here that Suzanne showed us. We were consuming data from our volume location. We're consuming our data into a bronze table here. And then from that bronze table, we're validating this into our CMS cost table. But this bronze table, we're incrementally ingesting new data continuously. And so what we'd love to be able to do is navigate to this quality tab here and be able to set up a monitor on this table. We can set up different types of profiling metrics. So we can do a snapshot, which does full quality metrics calculated over the entire table. We could do a time series profile, which leverages quality metrics aggregated over time windows. And then inference profiling. So this would be great for that predictions table that we have, where we're writing out of our predictions to our Delta table to be consumed. This allows us to track some of that information. And so for each of these different options, we can set a refresh schedule, we can set notifications, and then we can choose where all these metrics tables are stored. And you'll notice that they're stored right next to all of our other assets. So directly within unitycatalog, we just choose a catalog and a schema, and those tables get populated there. And then you can also choose an asset directory where the default dashboard configuration will be stored. So I've already set up one of these monitors here over the same data set. So if we go to the quality section here, this is what it looks like to be able to see once the monitor is configured. You can view the refresh history. So when all of these monitor metrics were ran each time, you can see the metrics tables that are being populated. In this case, I'm writing them out to a separate metrics schema in my same column here, catalog here. And then we also get this out of the box dashboard. So this dashboard allows us to consume these tables in a way that allows us to explore the information. So this table gets created for me by default on top of those metrics tables. I can see over time how the process data is changing. I can see percentage of nulls over time, and I can filter by different columns to see how that's changing with each refresh of data. And all of these visuals are just backed by SQL statements on top of those metrics tables that we have. And so we can configure this as an alert to get information and take proactive action if we start to see skew or drift across any of our tables. So Lakehouse monitoring is one way that we can start tracking data quality. The other way that we have this is to be able to start looking at our system tables. So within your catalog here, you'll have the system catalog, which has a collection of schemas. Each of these schemas will have different tables based off of the schema we're looking at. So in the billing schema, we have our usage and list prices. In the access schema, we have all of our audit logs. In our lineage schema, we might have some more lineage information to see how our tables and schemas are interconnected that we can report on in Common SQL. So all of this is provided for you, managed by Databricks. And because these are tables directly within unitycatalog, I can actually go directly to a SQL editor here. I can query against these different system tables to get answers to complex questions. So here, I'm actually trying to figure out over time which SKUs or which types of activities within Databricks have had the most growth. So here, I'm able to see the growth rate between April and May of our serverless SQL compute here, the interactive compute, and you can see how this could be really powerful for your admins to start taking action on this information, understanding more how your users are using the platform, how they're interacting with different data assets. So all of this you can do on your own with your own SQL queries against those system tables. But like I said, we do have a preview feature now that from your account admin, you can deploy a dashboard that looks like this. So this is backed and powered by those system tables in unitycatalog. We've just done some of the heavy lifting to build out these visualizations to make it easy for you to consume this data. So if I wanted to look at the interactive compute here and what's been consumed over multiple periods, I can very easily see that trend over time and take action based off of the information that's being surfaced in this out-of-the-box dashboard. So we have the complete picture now. We have all of those files through to tables, our AI assets, governance layered and in, consumption for our internal team, sharing with our external partners, auditability and visibility into all those assets. And as we mentioned at the start of the webinar, unitycatalog is now open source. So this is open APIs and open source server gives you maximum flexibility. It's interoperable, so it's a universal interface. It'll support the formats, engines to allow you to interact with your data and AI assets. And it still supports that unified governance. So bottom line for this unitycatalog open source, any engines, so your client ecosystem, you'll be able to consume from. Any client is a universal standard here. Any asset, so all of those data and AI assets that we just looked through, and any format, including the uniform format, to layer on top of other open standards. So right now we're in unitycatalog open source v1, which does allow us to leverage that open API spec to interact with unitycatalog assets without connecting to like a serverless SQL warehouse or any of the compute layers that Databricks is managing. So we can see a demo of this right now. So I am just going to pull up a terminal here, and I'm going to use DuckDB from my local computer to start consuming from my using these open source unitycatalog assets to consume those Delta tables. So here I'm just installing a couple libraries. This includes the interface with our open source catalogs here. I'm not configuring any, I'm not doing a JDBC connection to a serverless SQL warehouse or connecting to a cluster or anything. This is just running on my local machine. And you can see here, because I'm using this open source integration with DuckDB, I can attach directly to that catalog that we had set up previously. And I can start selecting against those data tables. So one of the tables in that three-level namespace that we had is that CMS drug table here. So I can run this select query directly on my computer, on my local machine here. and it will reply back to me with the information that I have for that particular table. So this is all of that data powered again by those open APIs that allows me to leverage all that good unified governance of Unity Catalog with any clients, with any engine, but still respecting all of the governance and goodies that are involved in UC to begin with. So what this is really doing is it's giving you an open ecosystem for how you can leverage Unity Catalog. You're not locked in to any one tool. If you're building out your governance strategy with Unity Catalog, it allows you to apply governance to any data and AI asset, consume it from any client, and use it wherever you need. So you can learn more from our Unity Catalog website. You can connect with us on LinkedIn with the Unity Catalog project. You can participate in GitHub discussions. This is the GitHub repo for Unity Catalog. And we would encourage you to join our Slack community. So questions, discussions, comments, ideas, we'll take them all. And if you're a Databricks customer and you want to start leveraging these open UC APIs today, talk to your Databricks account team to sign up for the external table access preview. We're continuing to push out new versions of Unity Catalog. This is just V1, but we're committed to making this a part of the open ecosystem. So now that we have all of these different features, functionality, governance, we've run the whole gamut here. How do we really put all this together for our governance strategy? What are some organization and access patterns that we should configure? So how many catalogs should I actually think about configuring? What are some common access patterns to catalogs and those assets when we're talking about scale across multiple business units, multiple groups within a company? What data isolation controls do I have and should I be using? And how should I design my multi-cloud or multi-region deployment? So Unity Catalog offers layers of isolation features. At the top layer here, we have that delegation of management. So we always have that Metastore admin. But as Suzanne mentioned, we can apply different business unit groups or users as owners of particular catalogs. We can also bind catalogs to particular workspaces, so you're not able to access it from any other workspaces. And then those catalogs can be backed by different storage locations. So you also get that physical isolation of the data storage itself across your cloud storage. And you can use any different combinations of this to support your end users. So as you're deploying Unity Catalog and onboarding additional business units, you might apply different admin groups from those business units to manage those catalogs. They might all have their own separate isolated storage locations. And then they might be connected to a single workspace. So we can only consume these catalog assets from workspace A. Or a workspace could be connected to multiple catalogs. So workspace B, we can consume catalog 2 or catalog 3 here. So this really gives you a lot of flexibility. Maybe business units B and C are collaborating on different projects. And so workspace B should be able to access this data here. But with these levels of isolation, you can support any of the security requirements that your organization might have. So if we look at sort of a practical permissioning example, what you might start out with when you have your Metastore is maybe your central or your enterprise IT team creating catalogs at the development lifecycle level. So maybe you'll have your central team creating dev, staging, and prod catalogs here. And so the owner of these catalogs might be that central team. And maybe they might, for the production catalog, grant usage access to downstream business units. As these business units get more mature, it might be that the business units themselves have their own dev, staging, and prod catalogs. they might actually be the owners of those catalogs, facilitate all the schemas and tables created within them. And then they might have full control and then maybe grant usage access to business unit 2 and even to the central team for support. And finally, that last business unit, you can continue to follow this pattern of deploying additional catalogs to allow isolation between your business units and giving them full control and ownership of those assets. When we put all of this together, you can see within your Metastore in a region, you'll have many different types of catalogs. Across all of those catalogs, they could be accessed from many different workspaces. And your users and groups might have access to only a subset of workspaces. And depending on the workspace they're in, they may or may not have access to all of the catalogs that they can view. So as a best practice, separate catalogs by responsibility. If you're following a development environment lifecycle, maybe separate catalogs for dev, QA, and prod. You might also require separate catalogs for business units, or even for your sharing, like Delta shared catalogs or your foreign federated databases. Use workspace catalog binding where required, but ultimately, create the minimum amount of assets required to meet your team's isolation and ownership requirements. With great power comes great responsibility. So we don't want you creating, a million assets that then kind of explodes out the maintenance that you have to do on top of those assets. So you have a lot of control here, but make sure that you're able to only create those assets that you absolutely need. Have a reason for creating those new assets. Within any workspace, you'll have the compute that allows you to interact with Unity Catalog here. So if you're a longtime Databricks user, you're probably familiar with interacting with the Hive Metastore. The Hive Metastore, this no isolation shared clusters, these are now considered legacy. They won't interact with any of the UC governance. So when you're deploying with UC and interacting with UC, you'll be deploying one of these 3 types of clusters. So access mode shared, which allows multiple users to share the same compute here, or single user clusters that can be assigned to an individual user when that cluster is being created. Coming soon, you'll be able to assign these single user clusters to a group. So a collection of users, all those users within that group will be able to leverage that same single user cluster, which would allow them to leverage like the Databricks ML runtimes if they wanted to. And then finally, these single user clusters, you'll have fine-grained access control coming to these soon as well. So all of that RLS and CLF functionality that we looked at earlier. And then what is primarily probably going to be the consuming compute layer for most of your users is going to be our SQL warehouses. And probably I would recommend our serverless SQL warehouses. Multiple users can work in parallel, and our serverless SQL warehouses leverage intelligence to make sure that the way users are interacting and querying remains efficient and performant. As a best practice, use those shared clusters as your default compute for your workloads and fall back to a single user cluster in case of limitations. And another best practice would be, for the development and deploy, use the same access mode. So if you're developing a data engineering pipeline using shared clusters, when you deploy that pipeline to production, also use shared clusters. If you're developing using single user clusters, when you deploy that pipeline to production, also use single user access mode. This will just give you better resilience and expectations about how your clusters, how your workloads will perform once you get them deployed. And finally, data sharing. So you will not just have, in most cases, your workspaces in one region. A lot of times you're going to have workspaces across regions. And remember, a Metastore is deployed per region. So one way to be able to share assets in your Unity Catalog Metastore across regions is with Delta sharing, which we saw a few different ways of earlier today. If you have your workspaces deployed in multiple clouds, so maybe some in AWS and some in Azure, you can also use Delta sharing to share between those clouds. And then like we saw before, for any external companies, you can use Delta sharing that way as well. So Delta sharing becomes that single pane of glass for how you can manage sharing your assets internally and externally, cross-cloud and cross-region. As a best practice, set up a single region Metastore for your software development lifecycle and business unit scopes. So if you have your dev and QA in one region, maybe put your prod in that region also, and use Databricks to Databricks Delta sharing between cloud providers and regions, within your organization. So this starts to wrap up our webinar. We've gone from A to Z, from files to security assets. So now we'll take a look at some next steps. If you are currently a Databricks customer and you have not yet started using Unity Catalog, we would recommend that you take a look at our UCX framework. So this is a Unity Catalog upgrade framework. It's been leveraged by hundreds of customers. It gives you a complete assessment of the current state of your workspace and all of the assets being managed within that workspace, and then gives you a plan for how you can migrate all of those assets into Unity Catalog to make the process a lot easier for you. We also have a collection of demos, so you can get hands-on coding experience with all of the assets in Unity Catalog that we explored today with these demos. One I might recommend is our Lakehouse for IoT and predictive maintenance. It takes you from file through data pipeline, through model training and model inference. So you really see the whole picture of all those assets that we saw today. We also have a Databricks tutorial on system tables. So this can help build another dashboard, so not the out-of-the-box dashboard we viewed before, but a custom dashboard built on top of system tables that can help you understand how you might interact with them and what type of queries you might ask against those data sets. We also have a collection of documentation, feature-specific demos that you can pursue and take a look at as you're starting to learn and take advantage of these different features. And then we finally do have an ebook here on data analytics and AI governance. So how can you effectively build your governance strategy for your data lakehouse? What should you be thinking of? What are some best steps and best practices that you should be taking? So a lot of this we covered in the webinar today, but this will give you some additional context that you can reference. So I want to thank everybody for hanging in there with us. I know we covered a lot of ground today. The recording will be shared out with attendees within 24 to 48 hours. The slide deck will also be included in that share out, so you'll have access to all these links that we went through today. If you have questions, I think we still have Q&A open for just one more minute. We'd appreciate it if you complete our exit poll, give us feedback on what we should include, not include, do more of in webinars going forward. Yeah, and thank everybody for attending today. One question I see here, are we able to move Hive Metastore to Unity Catalog at the workspace level instead of account level? So Unity Catalog is an account level concept, but to kind of mimic what you would describe, I would say deploy like a workspace specific catalog and then uplift your Hive Metastore assets to that catalog for that particular workspace, potentially as like a first step. But what Unity Catalog really does is makes it easier for cross workspace access potentially, depending on those isolation configurations that you have. All right. I appreciate again everybody's attendance, great questions throughout the session. We hope you enjoyed everything and get started using Unity Catalog ASAP.